Okay, just for extra information, this picture was taken, as I think I mentioned this, but in the museum in Paris, because for years and years, people who are artists, people artistically minded people have found beauty in mathematical structures. This, again, is a circular hyperboloid, right? Interesting thing is, this beautiful curve actually does not consist of any curves. If you think about these lines here, all of these are actually straight lines. In fact, you can get a bunch of straight lines or straight sticks or something if you have enough of them. And if you twist it, you actually get this beautiful hyperbola. And so it is possible to make this, what we call, the mathematicians call this a negatively curved structure, simply by connecting all these straight sticks, which is quite amazing, right? And so, you know, there you go, circular hyperboloid. And I said this many times, but there is technology available, such as apps and websites, and you can look up these places. I personally use the one called Good Grapher, which is a free app. You can pay extra to upgrade it. And this one was drawn, I think, using Wolfram Alpha. Wolfram Alpha is a website that will let you graph certain things. This is the company that makes a program called Mathematica. And what you see here is a sketch or the picture of, what do you think? It is the saddle or the hyperbolic paraboloid. You can see the parabola here. It's a downward parabola. Here's another parabola, upward parabola. And then for the Z being constant, you will see hyperbolas. So this is your hyperbolic paraboloid, otherwise known as a saddle. So I would encourage you to, you know, experiment with this, and it is a lot more fun than just watching a boring TV show, actually. What do you have here? It's some sort of a you see a hyperbola here, right? And if you cut it vertically, you'll see an ellipse or a circle, right? And so this is an example of an elliptic hyperboloid. So you have an ellipse, and you have this hyperbola, and then there's other hyperbola if you cut this in the by a horizontal plane. So an elliptic hyperbola of two sheets, obviously, right? And so here's the equation of that, and you can enter f of xyz, some equation in xyz, and Good Grapher and other apps will graph this for you. I am very proud of my hometown of Kobe, Japan, K-O-B-E, pronounced Kobe. And this is where I was born and raised. And here is the circular hyperboloid. You see the circle? If you cut this across any horizontal plane, you see a circle. And there is your hyperbola. And in the perpendicular direction, you also see an hyperbola. And this tower called the Port Tower of Kobe is actually exactly as old as I am. And this right next to it, this is a newer construction at the harbor of Kobe. And this is an example of pretty much the saddle. Okay, so this is that hyperbolic paraboloid. And here is a saddle point. So nice and elegant. Right? But you can do all sorts of other things. If you want to see the cross section with a horizontal plane on these apps like Good Grapher, all you have to do is to sketch the surface, and then let z equal 1, z equals 0, z equal -1, and you can see these what we call cross sections, or later we'll be calling these curves contour curves or level curves of the surface. So it's very nice to see these things. All right, so again, encourage, this is parametric curves on the plane, define x in terms of t and define y in terms of t. And this technology is readily available, literally in your hands. So I think this is something that you should actually download and play around with, okay? And that's all because, as this little pencil case says, art is more important than mathematics. Who said this? Right? Well, actually, my wife, who is a pure artist, like oil and watercolors painting, she picked this up at a museum. And so what I decided to do is to cross out a few words. Yes, math, or art is math. All right, have a great day. Take care.